手机开的话，我在哪里看弹幕呢？Oh, I cannot see chat box. I have to use the computer. Use the computer and find the link. Where is the link? Okay. So we only got the 11 questions for the open, but only 2 questions from junior. So maybe today we just talk about all the open 7 questions. The first 7 is same for open and junior. And then only the last part differs. But then, so for the last 8 question of, I should mute myself. So for all the 8 question of the junior, I only collect 2. So if you remember, so again, junior student here, and you remember the junior question, share with me. So first 7 question is in common, and maybe we can just start. The first question. So write 1 to 8, each once, ignore spelling mistakes, right? So now we want to make this fraction closest to 1. So now if we make the fraction close to 1, so numerator should be close to the denominator. So we can find the sum of 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, all the way to 2 to the power of 8, equals to 5, 1, 0, 1, 2 minus 2, right? 2 to the power of 9 minus 2. So it's 5, 1, 0. This is something we can know. And so now for which, after that, we just need to make the numerator denominator should be close to half of the 512, so which is a 255. But then we do know that this 2 to the power of 8 itself is already a 256. So we should give the 2 to the power of 8 as small number as possible. So we give the 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. Right? So we make a 270. And the rest, sum is the 240. Right? So the fraction value, it can either be 240 over 270 or 270 over 240, but then which one actually is closest to 1? So now we just find the difference. So this one is 1 minus 1 over 9. This one is 1 plus 1 over 8. So obviously 1 over 8 is larger than 1 over 9. So the first one is closer to 1. So this is the sum we need, right? So the answer is 8 over 9. I think the first question is easy. And the question 2. Question 2 is something about general term. Right? So now you will see that each of the term here is the n times n plus 3, then plus a 2. This one is the n squared plus 3n plus 2. This cross the factorizer is the n plus 1 times n plus 2. Yeah, a basic factorization. And so now, after that, what can we see from here? So the first part, you see the 2 is the n, so it's the 3 and 4. So which means the fraction, the denominator, the first term is the 3 times 4. The second term, 4 plus 1 is 5, so times 5 times 6. And now all the way to 2024 plus 1, 2025 times 2026. And then the denominator is the 2, 3, 4, 5. And then 2024, 2025. So now we can cancel out everything in the middle. The only remaining is the 2026 over 2. 1013. 1013. So now the second question is also easy. And question 3. Question 3 actually, so if you just use the number notation, it's okay. And if your number notation is okay. However, right, so we do have a more easier way by using the combination number instead. So this one is actually the same thing. So now if you draw the graph like this, right, so it's the same thing, like find the shortest path to go this picture from the top to the end. Right? Isn't the same thing? So now this shape then can be treated as a 5 times 5 square grid, right? So now it's a 5 times 5 grid. And then from the left most, so the left bottom to right top. So which means the method is simple. So we do have the, so now in total, just we have 10 steps. 5 to go downwards, 5 to go leftwards, right? So, or rightwards. So 5 upwards, 5 rightwards. So it's the total method, just the 10C5. 10C5 is the 252. That's the 252. It's also easy. With your number notation, you can still get the correct answer, I think. Right? And then question 4, number 0. A, B, C, D, E, F is a 6-digit number. C, D is divisible by 3. B, C, D is divisible by 5. A, B, C, and D are divisible by 4. So someone said it's about number of all different A, B, C, D, E, F. Someone said it's listing all the A, B, C, D, E, F. But I think both are okay. No, didn't make any difference. So now the logic is A, B, C, D, E, F here. Right? So first, B, C, D is divisible by 5, so D is the 5. CD is divisible by 3, so which means the C and E, the sum of C and E plus 5 is a multiple of 3. And then also we know that BC is multiple, C is even. And then F is even. So we can start with the C. It's adjacent with this 5 and it's even. Now C could be 2, 4, or 6. Right? The first case, if C equals to 2, then 2 plus 5 plus E is a multiple of 3. So E must have remainder 2 when divided by 3. Now, E can either be 2 or 5 or 8. The problem is we already used the 2 and used the 5. So no solution in this case. And secondly, if C equals to 4. So if C equals to 4, then we will find out that 4 plus 5 is already 9. So now E has a remainder 0 when divided by 3. Now, before we start to discuss about the value of E, there are another thing you need to focus. So now you see BC is a multiple of 4. C is a 4. So, which means if the last digit is a 4, then 10th digit must be even to make a multiple of 4. So, which means in this case, B must be an even number. And then F is an even number. We only have 3 even numbers, 2, 4, 6. So, which means E must be odd. So, which means E must be 3. Right? E must be 3. And then, so B and F is the 2 and 6. Both will be okay. And then A is the only one. So, we have 2 numbers in this case. 1, 2, 4, 5, 3, 6. 1, 6, 4, 5, 3, 2. Right? So we have 2. So the third case, what if C equals to 6? Then if C equals to 6, in this case, B must be odd. Right? B must be odd. And then E would have remainder 1 when divided by 3. So now E could be 1 or 4. But try 1 first. Try 1 first. So if E is the 1, then in this case, F can only be 2, right? F can only be 2. And then for the 2 remaining number here, am I correct? So now 1, 5, so B must be the 3, and then A must be the 4. Right? So we have the 4, 3, 6, 5, 1, 2. Okay, this is the third case. So can E be 4? Actually, E cannot be 4, because if E is the 4, and then F must be the 2, but 42 is not a multiple of 4. So this is impossible. So now we only have 1 case here. So in total, 2 and 1, we have 3 cases. Right? Question 4. It's not very easy. No, I think it's very easy, but it's just not very simple. So easy. So this is called the maybe also easy question. Maybe also easy question. And question 5. The product of these 4 numbers divided by 26 squared. So 2 is very easy to satisfy because we have 206 and 06. We already have 2 2s. Just about 13. So which means among these numbers, there must be at least 2 numbers that is multiple of 13. Right? So we just need to check. So first, about the, so if we want to make the 13 can divide this A206. So which means 13, we just use the difference of every 3 digit, so can divide 206 minus A. So A must have the same remainder with 206 when divided by 13. However, we know 208 is multiple of 13, so A has a remainder negative 2, which is 11 when divided by 13. N is a one-digit, N is one-digit number, N cannot have remainder 11, so we don't have a solution here. So which means no solution in this case. So if we have no solution in this case, since this one can never be multiple of 13, so A just try to be as large as possible. We let A to be 9. Right. Okay. Then secondly, let's see that for the 2B06. So if 13 divides this 2B06, then 13 can divide this B04. Right? The difference of B06 and 2 is the B04. And then in this case, we know 104 is multiple of 13, 13 times 8, right? So which means B must be 1. B must be 1. So at least we find the number to make a multiple of 13. Okay. But the third case, where 13 divides the 20C6, and then 13 can divide the C6 minus 2 is the C4. And then if end up with 4, at least the multiplier must be 8. 13 times 8 is 104. No, it's too large. So which means, so C must be 10, so which is impossible. So again, since they can never belong to 13, we just make C as large as possible to be another 9. Finally, if 13 can divide this 200D, then so 13 can divide this 6 and D minus 2. So we know that 65 is multiple of 13. So we just make the D minus 2 equal to 5. So D equals to 7. Make it work. Right? So at least we find a solution just here. So because A and C can never be multiple of 13, we just make them to be 9. And then B and D can be multiple of 13. So 1 is 7. So the maximum sum is the 9197. So which is the 26. But actually need to check one more thing. Because for the two multiple of 13 here, is it possible that one of them is a multiple of 13 squared? If that thing happens, if one number already produced 2 of the 13, we don't need another number to be the 1 or 7, can all be 9, right? So we check about the two numbers, the 2106 and then the 2067, to divide it by 13 and to see whether this one is multiple is a multiple of 13 squared or not. 2016 divided by 169. 2106, sorry, divided by 169. This one's not. And the 2067 divided by 169. What's wrong with my calculator? It's not. Both of them are not. So we don't need to worry about that. Yeah, we don't need to worry about it. Okay, so generally the answer is 26. I think since there's no trap for this question, I think this one should be easy. I think this one is also easy. And then question 6. Oh, question 6 is describe a case. I need to draw a proper picture here. If I don't have a proper picture, it's a disaster. First, I draw a square. Suppose it's a square, maybe. And then I draw, it's not a square, by the way. But make it more likely a square. Okay. And then I should draw a equilateral triangle. Equilateral triangle, which goes. Then this equilateral triangle must have exactly half the silence. Is it half silence? Just about it. Just about it. Okay. So I just prepare this two picture, copy it for. Okay. So now it says that we want to rotate this triangle. This is the x. This is the y. We rotate this triangle and then all around this square until the y go back to the original position. So now, the first rotation, right? If we make this triangle, I just use this. Oh, no, it's not. So the first row, oh, no, I should make it smaller. Actually, I should make it smaller, slightly smaller. Yeah, this is better, right? So now the first rotation comes in this place, and then so now during this process, you will see that the point y goes here. That's the y prime, right? So the rotating center is here, so the rotating angle is a 120. It's a 120 degree. So first we rotate it for 120 degree. And then do not forget that when you hit the corner, we have one more move. So we need to make this triangle to another side. So in this case, we should rotate this triangle here. I change another color to make it better to see. Also, I copy it. And then, so I rotate this one. Oh no. Why is that? Why is this one not that convenient to use? Okay, so now we have the second rotation step. But for this step, y isn't moved. So we ignore the y. We ignore this y. Right? So now, in this case, y is now at this place. The second movement needs us to rotate this triangle. Right? Rotate the triangle here. And then where's the y now? Where's the y now? So now you would see that, so this point, this remains unchanged. So y, so this point goes here, y goes here. So this is new y prime prime. This is the y prime prime. Now the second rotation y prime prime is another 120 degree. It's another 120 degree, right? But then, so here's some important thing. So now when y prime is here, the next movement is make this triangle close to the top. And this one also caused the y to rotate. So again, I change another color. Which color I didn't use? This one? Yeah, maybe. So okay, we should make a triangle in this direction. Then you know that's right. So now, during this process, you need to rotate the y from here to here, right? This is a 30-degree rotation, right? This is a 30-degree rotation. So now we have another 30-degree movement of y. So now the new y is here. The third movement actually remains unchanged. Third movement, the y always keep unchanged. The third movement makes the y in this direction. Yeah. So now y is always here. Y is always here. Okay, then again, we rotate this y. We rotate this y. And then we need to make this triangle to another side. And in this case, change the color maybe. Which color? Maybe green. Yeah, the last one. Right. So now, the last turning of this y is another 30 degree. So now I stop it here. But why I stop here? Because now you would see that look at this triangle and this triangle. So after this rotations, so you can find out that y finally go back to y's original position, that is the top of this triangle. But then this whole triangle didn't go back to the original position. This triangle has to travel 3 sides counterclockwise, or you can say traveled 1 side clockwise, right? So now which means this is called the one period. This is one period. So by doing one period, so we can make the point of x. So now the x is at the position of the x. Z is at the position of the z, right? So we actually make the x, y, and z. The relationship between them is the same. So if you take this whole picture 90 degrees, so it's become the same. But then the position of the triangle is not the same. So if you want to make the position of triangle also become the same, we need to repeat this process for 4 times and move the triangle here, 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 and finally go back to the original position, right? So which means 1 period for rotation for x, y, z, 4 period for the triangle to go to the original position. So now the total distance traveled by y is the distance traveled by y in 1 period times 4. So we know that in one of the period, 120 degree, 120 degree, 30 degree, 30 degree. So in total, we have 300 degree, right? So the total distance is the 300 over 360. and then times the circumference, which is, this is 3, right? This is 3. So now times 2 pi times 3. So this is 5/6. So it's 5 pi. So one period, the y travel 5 pi. So times the 4, y travel 4, 20 pi. So here is the 20. Oh, well, I don't think this question is easy. I don't think this question is easy. At least a normal question. It's not that hard anyway, but it's very easy to make mistakes. So far, many students, right, so didn't make it correct. So maybe just a normal or hard. It's not hard. It cannot be hard anyway. Okay. Question 7. Question 7. Angle calculation. 32 degree, 14 degree, AB equal to BD equal to CD. This is also 14 degree, right? So now, we obviously, for this type of triangle, we cannot use a normal way for it. It's impossible. So now, if you are just using the simplest way, you can use the sine and cosine, using the Sever law for it. I think it's okay. Using Sever law is okay. But then, obviously, that's too complicated. So now, if you don't learn the secondary school method, we always have one way of doing this, just to form a equilateral triangle. But where can we find the equilateral triangle? So we can find relationship with the given angle and the 60 degree. It's not that hard for you to find. 32, 14 plus additional 14 equals to 60 degree. So now, we find out a way to lead to 60 degree. We will know how to solve this question. So we want to make another 14. So maybe we just draw this picture downward symmetrically. So we create a D prime here. Now, BD equal to CD. This is a 14 degree. So now, if you connect this ABD, the ABD prime, so now you will see that the triangle ABD prime is equilateral. The triangle ABD prime is equilateral triangle. So which means AD also equal to AB. So AD prime, D prime, C, they all equal, right? They're all equal. And then, so now, which means this is also an equilateral triangle, and we know this is 60 degree. It's easy for us to find out all because this is 14. So here is the 120 minus 28. 100 minus 28 is 100 minus 28 is the 92. This is 92 degree. If there's 92 degree, so we will see the total D prime AC. The D prime AC should then be 180 minus 92, 88 divided by, so this is, the total is the 44 degree. The total is 44 degree. And 44 minus the 28, so this is a 16 degree. So this is 16 degree. This is 16 degree. Okay, right. So now, this should be normal or hard. So the problem is this question is not easy to be measured. So usually for this type of question, we always say that measuring is always one of the best ways. However, for this question, it's not easy to measure. Some students just draw the standard picture to measure it. And then they will find out that it's only, someone got 15 or 16. No, the answer is 16, right? Someone got 15, someone got 18. So the answer is 16. It's not that hard because it's the real hard angle calculation is way harder than this. I think it's maybe a normal, just a normal. Question 8. I don't know how to say about question 8. I don't know how to say about question 8. So maybe it's just about the, it's normal, between normal and hard. Between normal and hard. So now, which means, if you learn the primary school, if you learn the secondary school, it's normal. If you didn't learn secondary school, it's hard. It's very hard. Right? So now you don't know how to solve it. You have not found any way of solving. So this is a 3-degree equation, and there has only 2 solutions. So first, you understand, right? For 3 degree, we must be able to factorize it. This one actually is factorizable. So how to factorize it? It's not that clear for you to see, but then there is some hint. So this is x, this is p squared, right? So now x, so it's supposed for us to know that something about x combined with p and then p squared. So now we can just try, because x cubed minus p, so you can try it as the x cubed minus a px squared. So suppose x minus p is one of its factors. So now if it works, and then the extra part is the minus px, minus 1x squared. And then the negative 1x should match with the positive px. And then the extra is the px minus p squared. So now we just have a try. We suppose x minus p is one of the factor, and we find it out it's actually d factor. It's actually d factor, right? So now which means it can be factorized as the x minus p x squared minus x plus p equal to 0. Right? So the original equation, right, becomes this way. And then, so we know that this is a 1 degree times a 2 degree. For linear, so the 1 degree always have one solution. However, right, for the quadratic equation, x squared minus x plus p, this one is complicated. So now this one have 3 possible ways. So the first is it has no real solution, which means when delta is smaller than 0. And secondly, we have 2 equal solutions. So why I write 2 equal solutions? Because in the result, it's only one solution. But it's more accurate for us to see the 2 equal solutions. But basically speaking, so if the first one have one solution, the second one have one solution. Right? So now in total, we have 2 solutions. Right? So now, it doesn't work, right? It doesn't work. And then for this one solution, right? So the delta must be 0. So 1 minus 4p equal to 0. So p equals to 1 over 4. Right? So in this case, p equals to 1 over 4. And then question 3, the part 3. Right? So the part 3 is, so now this could have 2 unequal real solutions. So seems that for this question, so this one has 2 solutions. And so it should be 1 and 2, you have 3 solutions. Should have 3 solutions. So, but it could be a special case happen here, that is to say, what if one of these 2 solutions is same as one solution here? Is it possible? Right? It's possible, right? So if we want this case only have 2 solutions, which means one of the solution among these 2 is same as the one solution here. So this one, the solution is the x1 equals to p. Right? So now in this case, so now if in total 2 solutions, so if x equals to p is a solution of x squared minus x plus p. Right? So now in this case, so you would see that we have p squared minus p plus p equal to 0 to get p equals to 0. So now if p equals to 0, then this equation, right? Then this equation actually makes, right, p is one part of it. And then so we bring it back to the original expression. This one becomes the x squared minus x cubed equal to 0. So it's the x squared x minus 1 equal to 0. This one obviously have only 2 solutions, 0 and 1. So actually p equal to 0 also make it work. So now in total we have the 1 over 4 and 0, so we have 2 possible values for p to make it 2 solutions. This one is hard. First, you need to know how to factorize it. Second, you need to understand how the solution of a 3-degree equation works. Right? So this is a really hard question. So which means I think maybe ignore it. It's hard. It's just hard. Very hard. Okay. Then question 9. At least the first one is very easy. Fill 1 to 4 for every row and column. So now to make the sum of every row and column is impossible. Right? It must be 0. I don't even want we're working for it. So actually you need to write a general working for this, because, right? So if sum is even, so now if sum is even, means all grid shares the same parity. So all grid must share the same parity. So which means we must have the impossible. The answer is 0. The second part, we want to fill 1 to 9, the sum of every row and column. Actually, every row and column. That's all. Right. So how many ways are there? So this question actually, because we know that the sum being odd, the sum being even is only relevant by the number of odd numbers in each row and column. Right? So instead, and which value is this odd number? Doesn't matter. It could be anything. Right? Generally it could be anything. So now that's to say, so how to write the number down. So instead of finding the number distribution, we just say this: we have 5 odd, 4 even. in this 3 times 3. So where do we put odd and where do we put even? So ensure each row and column have a odd number of odd, right? So now we just count by row. So now we count by row the number, because we have fewer even, right? We have fewer even. The number of even, how to distribute the number of even. So each row either have 3 odd no even or no 1 or 2 even to make the sum odd, right? So now, which means in this case, the number of even must be 0 to 2. We have 4 even, so which means there must be 1 row with no even, and then 2 rows each with 2 even. Okay, so first we know the number of the distribution of the even number. So if you want to put them inside, if you want to find their position, first we do a 3C1. The 3C1 means that we choose 1 row to be 0. Because we already know that one of the row has no even number. So where is this? Maybe just, we have 3 ways. Suppose it's the first. Right? The first row have no even number. And then which means for the rest of the region, we have 2 in each row. And then, so we have 2 even number in each row. The second problem is, how do we put this 2 even number? So it's not hard for you to realize that, because instead of the row, we also want the column to be 2 or 0. So which means if this, for example, if this is even, so if the second row, 3C2, so now we put the even in the 2, right? So suppose we have the 2 even number here. So now this 2 column already have 1 even, 1 even. 1 even cannot make the sum odd. So we must make the third row, the even number should also be here. So the second row and third row, the even number must be in the same column. That is to say, we must have, so the 2 and the 3, after the second row determined, the third row is already determined. So now you will see that in total, we have 3 times 3. We have 9 ways to put, 9 different places to put our even numbers. The rest 5 is odd number. Okay. So now we determine the position. Then we determine which number we use. Because we change the even number, change the odd number, doesn't change anything about the sum's parity, right? So which means we will make it as the free arrangement of all the even, free arrangement of all the odd. So times everything together to be the final answer. So it should be, what is the answer again? I don't want to calculate it. Maybe I calculate it again. So it's about the 3, 1, 24, 120, 25920. 25920. Total weight system. So, normal? I think normal. So 10 is between easy and normal. It's a pure second question also. But at least you can use primary way for it. You can use the Pythagorean theorem. I don't want to do that calculation, but then actually the calculation is very complicated. Using the vector is the easiest way. But then since we are doing live stream, we don't use the vector method. I will solve this question with vector. But we first draw the coordinate system. A is the 0, 7, 1, 2, 3, 4, 5, 6, 7. This is the A. B is the 3, 8, 1, 2, 3, 8. Okay, B is here. So now C is the 2K, which means C lies on this line, right, parallel to y-axis. And then C could be anywhere. Maybe this is C. 2x, 0, 7, 3, 8. Okay, so now I don't start with the vector method, because using the vector, if we know how to use vector, of course we know how to solve this question. We just talk about something that if we don't know how to solve it. So we know this ABC is a right angle triangle. You can say which angle is right angle. So generally we have 3 cases. The first case is the angle ACB is 90 degree. The second case, ABC, a 90 degree. Or the third case, the CAB is 90 degree. We have the 3 cases. And then, so how to solve? So how to find this? We can use the Pythagorean theorem if we don't know vector. Pythagorean theorem, first, we can just express the square of the three sides. So first, AC squared. So AC squared equals 2, right? Because this one is the 2. So it's the 2 minus 0 squared plus 7 minus x squared. Right? If you extend it out, it's the x squared minus 14x, then plus a 49 plus 4, 53. Okay. Similarly, we have the AB squared. AB squared is a constant number. It's the 3 squared plus 1 squared equals to 10. Yeah. And finally, we have the BC squared. Now, BC squared is the 1 and 8 minus x. Right? Now it's the 1 squared plus 3 minus 2 squared to be more accurate. Right? 3 minus 2 squared plus 8 minus x squared. X squared minus 16x plus 65. Okay, right? And then if we know one of the angle is 90 degrees, so we can just use the Pythagorean theorem to find out this x. The first, if ACB is a 90 degree, right? If ACB is a 90 degree, so now we would see that this pen is not good. Wrong. ACB 90 degree. So now AB is the hypotenuse, right? AB would then be the hypotenuse. Then which means we will see that it's the AC squared plus BC squared, x squared minus 14x plus 53 plus x squared minus 16x plus 65 equals to 10. Sounds weird, right? But actually you can simplify it. By simplify it, so you will get the x squared minus we can cancel the 2 on both sides, I think. 15x, 56, 65, 56, 55 plus 54 equal to 0. So this one can be factorized x minus 6, x minus 9 equal to 0. Solution of this, 6 and 9. Right, 6 and 9. Yeah, actually it's a k, it's not an x. Generally, doesn't matter, it's the same thing. And then, so the second thing is, the ABC. So if ABC is a 90 degree, if ABC is a 90 degree, then AC is the hypotenuse. In this case, ABC is a 90 degree. So which means we have the AC squared equals to AB squared plus BC squared. So it's the 10 plus x squared minus 16x plus 65, right? And then, so equals to, no, it's the, it's correct, it's the x squared minus 14x plus 53. This is easier to solve because we can cancel the x squared, so to make it a line. So we have the 2x equals to 75, 53 is it correct? Why it seems not correct? X squared plus AC squared equals to AB squared plus BC squared. It is correct. But then why the solution sounds weird? 75, 22. Oh, it's correct. X equals 11. Just X is above it. It's not downward. It's above it. Right. And then similarly, the third case, CAB equal to 90 degree. So we would have the CA is the x squared minus 14x plus 53 plus 10 equals to x squared minus 16x plus 65. So similarly, we will get this is the 2x. 2x will then equal to the 2x equal to 2, x equal to 1. So generally, we have 4 solutions. 6, 9, 11. Pythagoras theorem is not that hard. Calculation is complicated. Not that hard anyway, right? So generally, it's if you use a vector, it's very easy. If you use Pythagoras theorem, it's normal. But anyway, primary school student will be able to solve it. Yeah, primary school student will be able to solve it. So that's it, the question 10. Okay, find the question 11. Do you think it's normal or hard? I don't think it's hard anyway. It's easy to find out the answer. So I think it's only a normal question. But then many students said that they didn't even have the time for it, so maybe they did give up for it. It's okay. It's about estimation. Just about estimation. So now the first one. Yeah. So k and n in the set 1 to 9. And then, so it's the k plus m plus n. The sum of k and n is a two-digit number. And then the number, so now which means the digit formed by it, right? So it's also with the k and m and n. So if you find three numbers, their sum are using the digit from them. So how many ways are there? So the whole question is all about estimation, because we need to know that k plus m plus n, how large can it be? This is at most 27, so which means, so let this k smaller or equal to n, smaller or equal to n. The sum, 10th digit, must be at most 20 something, so which means k is at most 2. K is most 2. So we just try the case. So first, can k be 2? Actually, it's impossible, because if k equal to 2, k plus m plus n is at most 299. It's only a 20. So now, the only thing to make 2 one-off digit, because we don't have 1, is to make 2 at 0, which is impossible. We don't have it at 0. So k cannot be 2. So generally, k must be 1. So if k equals to 1, then k plus m plus n, right? So in this case, k plus m plus n is 1 plus something. So which means it's the 1 plus m plus n. So 1 plus m plus n in this case could be. So first, because this one is either 1, 1, 1m, or 1n. The last two cases is the same. So maybe we just write it as the 1m instead, right? So now if the sum is 1, 1, right? We're just using the two ones. Then we just make the m plus n equals to 10. So how many ways are there? We have 1, 9, 2, 8, 3, 7, 4, 6, 5, 5. Right? We have 5 cases. And then if it's 1m, then we have 1 plus n equals to 10. So now m must be 9. And the m could be anything, 1 to 9. But then to be aware, this n equal to 9, 119 is already counted once here. So which means we minus a 1. Minus a 1. So which is the 8. Right? So which is the 8. So we have 5 cases here. 5 cases in the first, 8 cases in the second. So 5 plus 8 equal to 13. We have 13 minutes. 13 minutes. Then see the part B, right? So the part B is, right? So now, A to the power of A, B to the power of B, C to the power of C is a 4-digit number. So this is most important information. Because the 4-digit number limits the range of this ABC, and this helps you quickly find out the answer. Help you quickly find out the answer. The logic is, in this case, we just make the. So let's do something. 1 to the power of 1 equal to 1. 2 to the power of 2 equal to 4. 3 to the power of 3 equal to 27. 4 to the power of 4 equals to 256. 5 to the power of 5 equal to 3125. 6 to the power of 6 is already larger than 10,000. So now first, so again, we just let the A, B, C. A smaller equal to B smaller equal to C. So now, obviously, the largest C. So first, the largest C must be smaller than 5. Larger C is smaller than 5. Because if C equal to 6, the sum is already a 6-digit number, a 5-digit number. Impossible. Impossible, right? C is the most of 5. But then can C be smaller? Can C be 4? No. Why not? Because see here, 4 to the power of 4 is 256. So which means, if C equals to 4, or maybe C smaller or equal to 4, then A and B are both smaller or equal to 4. So which means, the sum is at most 3 times of 256, which obviously is smaller than 1000. So if C is 4, then if every number is 4, cannot make a 4-digit number here. So it's impossible. Impossible. So which means, so C must be 5. C must be 5. And then, so now it's the a to the power of a plus b to the power of b plus 3125 equal to a 4-digit number. Then secondly, we discuss about the speed, right? We discuss about the speed. Now first, can b be 5, right? So now, if b equals to 5, then the sum is larger than 6250, so the 1000 digit is larger than 6. But we already know that there's all the digits used here from A, B, C, there cannot be a number larger than 6, so which means it's impossible. Now b is not 5. However, if b is more than or equal to 4, the sum is at most 3125 plus 256 times 2. Still, it's smaller than 4000. So which means the 1000th digit of the sum must be 3. If the 1000 is the 3, which means we must use one of the digits 3. Maybe b is the 3, or maybe a is the 3. We don't know. We don't know. But based on the one of the number is the 3. So one of the a and the b is the 3. Then we will say that it's the maybe the x. We don't know it's a and b. So x to the power of x plus 3 to the power of 3 plus 5 to the power of 5. So this one equals to 3152 plus x to the power of x. This is a 3 something something something. And then it's the rubbish time. We don't know this x, but since x is more than or equal to 4, so x can only be 1, 2, 3, or 4. Just try all the x equals to 1, 2, 3, or 4. Just do 4 calculations. And that's you would see that only one number. So now it's the x equal to 1. The sum equal to 3153. This is the only number to work here. So 1, 3, and 5. And this is owning combination here, right? The owning value of ABC shown here, right? Is the answer 1 or 6? I don't know, depending on how the question is asked. You only have one case. I think question C, ABC is a set, so the order of a set is not important. So the answer must be 1. No, the answer is 1. Okay. So that's all for the open categories. So I think, let's try to calculate something. So how many points should the top student should get? 1, 2, 3, 4, 5, 5.5, 6. Ignore this. Suppose everyone don't know how to do this. 6. And this is the first question is so free. So a 2, 8. This question, 2, 10, 10. And then the last one maybe a 1.5, 11.5. Yeah, I think 11.5. So I think for this paper, I think maybe the top 5 line is larger or equal to 12. And then the HD line, the top 15 line is about 8. Or maybe 8 is too, maybe it's just 9, maybe 9, I think. So that's my estimation. Okay, I didn't only have 2 questions for junior, so I don't start junior, so maybe just stop here. So now if I got the junior paper maybe tomorrow, so I will just write the full solution of this. Okay, so I think that's all. Fine, maybe wait for 2 more minutes and then we can end the stream.